we are Group 10 from ES8 and our team was assigned to investigate case study 1. So let's get right into it. So, this is our situation. Evercam owns a solar energy power system in a desert. We approach the problem of transforming solar energy into useful electricity while preserving carbon neutrality in our approach. This involves transforming solar energy that has been gathered from the sun into chemical energy, which is easier to store and deliver. However, before delivering the energy to other places, it has to be converted into other forms. According to the first law of thermodynamics, energy cannot be destroyed or created. In this scenario, the Labster's solar panels gather solar energy and transform it into electrical energy. However, this law also emphasizes the fact that energy can change its form. The solar energy must be transformed and stored as chemical energy in order to be usable. This procedure entails converting the solar energy that has been captured into a form that can be conveniently stored, transferred, and used later on. However, to achieve our goal, there are certain issues we are facing, such as the process of producing octane from CO2 has already been patented by other companies. Due to this company may not allow any third-party organization to also produce octane from CO2.
Nevertheless, through research, the most suitable compound that can replace octane is ethanol, as the production of ethanol is much safer for the environment compared to other compounds, as it's produced through hydrolysis of water. To continue, ethanol is also able to reduce air pollution while producing a high amount of water through combustion, and along with the ease of obtaining the compound, ethanol is definitely the most suitable replacement for octane.
As a result, we have two main objectives to achieve. Firstly, we need to convert the electrical energy generated into chemical energy in order to distribute the compound form to Evercam ESS plant. The second objective is to conduct a thermodynamic analysis on the chemical reaction to determine the optimum condition to produce the ethanol compound.
Before introducing alternative methods in producing ethanol, let us further elaborate on the choice of ethanol as a replacement for octane. Firstly, ethanol emits lower greenhouse gases, which improve air quality, and to add on, ethanol production may provide economic benefits that contribute to rural development and job opportunities, as its production relies on only agriculture resources.
Now, the main way to produce ethanol to achieve highly selective hydrogenation of more than 99% of CO2 to ethanol. First, start by preparing the reactants and necessary equipment. The main process is to obtain hydrogen gas from the electrolysis of water, powered by the electrical energy obtained from the solar panel. Once the hydrogen gas is obtained, the reaction to form ethanol can be conducted with carbon dioxide from the atmosphere and hydrogen gas obtained from the electrolysis as the main reactants. Ensure that these gases are pure and free from contaminants, then an IR-based catalyst is prepared. Next, set up a reactor vessel capable of withstanding high pressure and temperature and preheat the reactor to 180 degrees. The heat needs to be controlled at 180 to 240 degrees. A catalyst that is supported on IR-based catalyst, which is heterogeneous catalyst that have a process in which a single atom on the catalyst surface drives a catalytic reaction, is then added to the reactor. In short, IR1-IN203 single atom catalysts have a high TOFIR value up to 481H1. Next, inject carbon dioxide and hydrogen into the reactor vessel in a desired stoichiometric ratio. In this case, the ratio of CO2 to H2 is 5:1, with initial pressure of 6 megapascal.
The hydrogenation reaction of CO2 gas to ethanol occurs in the presence of catalyst. The catalyst promotes the reaction between CO2 gas and H2 gas, resulting in the formation of ethanol. The exact mechanism of reduction of CO2 gas by hydrogen and subsequent hydrogenation step. After the reaction, the mixture contains a variety of products, including ethanol, water, and unreacted gases. Separate and purify the ethanol from the mixture by different techniques, include distillation, membrane separation, or other separation processes to isolate and purify the ethanol product.
To safely deliver ethanol using a lorry, several steps needs to be followed. First, the tanker truck must be prepared by thoroughly cleaning and inspecting it to ensure its integrity and prevent contamination. Once prepared, the ethanol should be loaded into the tanker with great care, ensuring secure connections and closely monitoring the filling process to avoid spills or leaks. After loading, the tanker truck should be properly secured for transportation to prevent any movement that could lead to accidents. It is also essential to plan the route, taking into account road conditions and adhering for regulations for the transport of hazardous materials.
There are factors that affect the rate of reaction. Firstly, the concentration of the ethanol. Since the solar field was in the desert, the concentration of carbon dioxide that absorbed from the atmosphere is high, which will increase the formation of ethanol from the hydrogenation process to produce liters of ethanol. Next, the temperature of reactor. Increasing temperature will increase the effective collision between the reactant either in hydrogenation or combustion process. Heat release from hydrogenation is 173.7 kJ per mole will be reused to avoid any emission of heat to the environment. Lastly, the adding of catalyst. Ethanol is a homogeneous compound where it will have a selective catalyst, which is platinum mesh and rhodium or aluminum oxide foam. The activation energy on combustion of ethanol will be lower, thus will increase the energy release in a brief time.
Through the data given, we can see the standard entropy and standard enthalpy during the electrolysis process, which is carbon dioxide react with hydrogen gas to produce ethanol and also water. For the change of entropy delta S that can be calculated, which is negative 484.204 joule per Kelvin, and the change of enthalpy delta H is negative 216.1 kilojoule per mole.
For the combustion reaction, from the data given, we can see the standard entropy and standard enthalpy of each component in the combustion of ethanol. We can see that the change of entropy can be calculated, which is positive 217.6 joule per Kelvin, and the change of enthalpy is 1922.7 kilojoule per mole. We can assume that the Gibbs free energy for combustion of ethanol is always negative and does not affect on the changing of temperature from the formula delta G equals to delta H plus negative T delta S. If high temperature, the delta G will stay negative, and if low temperature, delta G also be negative. Therefore, we can say that the combustion of ethanol is spontaneous on forward reaction.
Kinetic and thermodynamics limitations. Since the temperature does not affect the spontaneity of the reaction, there is no limitation in the thermodynamics. We can see from the speed of the reaction aspect or its kinetic limitation. Addition of catalysts into the reaction will increase the product produced in a short time, while increase in temperature in combustion of ethanol will increase the effectiveness of its catalyst, which is platinum mesh and rhodium or aluminum oxide foam.
To summarize our case, Evercam ESS plant utilizes the principles of thermodynamics to convert solar energy into usable electricity while maintaining carbon neutrality. To enable storage and portability, the electrical energy is transformed into chemical energy, which are conveniently stored and transferred. In order for Evercam ESS plant to encounter its problem in replacing octane with other suitable compound rather than octane, ethanol is used as a replacement. Moreover, this reduces the reliance on fossil fuel burning and eventually decreases air pollution. The good advantage that comes along with ethanol includes the derivation of renewable sources while being an alternative to fossil fuels at the same time. This approach would also optimize the storage, transportation, and the utilization of renewable energy, thereby supporting the goal of carbon neutrality. Processes that are related to our research, the energy will then be stored in ethanol and will be obtained through the combustion process. In result to this, the ethanol can store a huge amount of energy which can be used in the future, and its purity towards the environment is proven in our case study. Thank you.